Hello again, everybody. Today we're going to take a look at exercise 13 in our analytical geometry booklet. And the focus of the lesson is a new form of the equation for a straight line, a linear equation, something called the point-slope form of a line. And then we tackle some problems where we actually get to use that new form of a line, that new formula, if you will, to solve equations where we're given a point and a slope, and we'd like to know the equation of the line. So to start off with, remember from grade 9 that there are a couple of ways you can write the equation of a straight line. You can write it as y equals mx plus b, where the m number is your slope, the b number is your y-intercept. Or you can write it in standard form. Usually we represent that as ax plus by plus c equals 0, where these two things are coefficients, that's a constant, and we could plug in numbers for x and y and make a table of values. Well, the new way that we're going to look at a line comes from the slope formula. And if the slope formula is new to you, then you need to look back a video or two. But just as a quick refresher, remember that slope is symbolized with the letter m, and it's thought of as the rise over the run, which is the same as saying the change in the vertical position divided by the change in the horizontal position of any 2 points on a line. We sometimes call that delta x and delta y, where the delta means the change in position. As a formula, usually we go back to the way we look at the coordinate notation in the distance formula and the midpoint formula. So we'd call the 2 points that we're looking at x1, y1 and x2, y2. So the slope formula ends up being this number minus this number divided by this number minus this number. Now, looking at an example here on a grid, this is the point 2, 3. And over here I have the point, I actually forget what this point is, 1, 2, 3, 4, 5, 6, so it's negative 6. 1, 2, 3, 4, 5, 6, 7, negative 6, 7. And if I want to know the slope of the line between these 2 points, or the line that passes through these 2 points, then I can count it directly. Its slope would be negative 1, negative 2, negative 3, negative 4, so its rise is negative 4. And its run is positive 1, 2, 3, 4, 5, 6, 7, 8. So that simplifies to a slope of 1/2. Now, let me simplify this a bit. First, let's take away the actual grid if I can. There we go. And let's say that I know that this point is 2, 3. Oops, I didn't need to do that. There we go. I know that this point is 2, 3. But I don't know the coordinates of this point. I have no idea what they are. I just know that there is, of course, an x number for that coordinate and a y number for that coordinate, but I don't know what they are. But I do know that this line that I've drawn through them here has a slope of negative 1/2. Could I find the equation of that line if all I know is one point and the slope? I don't know any other points on that line. And here's what we can do. Here's the situation broken down symbolically. I know the point 2, 3. I know the slope is negative 1/2. And I'm going to pretend I don't know this other point is negative 6, 7. I'm going to actually replace it with just any old x value and any old y value. So again, think of it as this is my x1, y1, and this is my x2, y2. And then I go to my slope formula. And I say, okay, well, I can replace the slope with negative 1/2. I can replace y2 in the formula with just any old symbol for a point y that I don't know, a coordinate y that I don't know. And y1, of course, I know is this 3 number. Then the second x coordinate, again, I'm replacing with just any unknown x value coordinate. And I'm subtracting my x1, which is 2. Now notice this already looks a little like the formula or the equation of a straight line. It has a y and an x. It's degree 1. All I have to do basically is cross multiply this denominator so that I now have this equation here. And I have a linear equation. Now I might want to tidy that up. That's not the way we are used to looking at a linear equation. It's not in y equals mx plus b form. It's not in standard form. So I could do whatever I want. If I wanted to change this to y equals mx plus b form, no problem. I will multiply both sides of the equation by -2. And these brackets don't really mean anything anymore. And then, actually, I'm sorry, I'm going to standard form here. If I wanted this in standard form, I would multiply this equation, the entire thing, by -2. And then I just move everything to the other side of the equation so that I have x plus 2y. And then when this 6 moves over, it becomes a -6. So that becomes -8 equals 0. So there we are in standard form. Or, again, I could have started from here and gone to the other form, where I would just multiply through this bracket and say that it's negative x over 2 plus 1, sorry, half of 2 is 1, equals y minus 3. Then move this to the other side, rewrite it backwards, and y equals negative 1/2 x plus 4. So there's the other two forms, standard and y equals mx plus b form, that I got simply by using my slope formula and 1 point. Let's do it without any numbers. So here's the situation. I have 1 point that I know. I'll call it x1 comma y1. And I have another point that I don't know, but instead of calling it x2, y2, again, I will call it just unknown y value and unknown x value. And let me just group that together. Let me move that up a bit. That's the best I can do. And group. There we go. So there's my equation right now, where again, I know the coordinates of x1 and y1. Remember on the last equation, I plugged them in. They were the numbers 3 and 2. So I know these two numbers here. I know those two because I have some sort of point that I was given. But I don't know the other point. That's why I plug in just the unknown x and y. And what I end up doing, what I did in the last one is, I cross-multiplied this up to here, putting it into a bracket. Of course, this doesn't mean anything anymore. And that right there is my formula that I can use to find the equation of a line if all I know is 1 point, its x and its y coordinate, and the slope to some other point, even though I don't know what that some other point is. Generally speaking, the point slope, and here's the way it looks in your notes, the point slope form of an equation is this. We usually write it with the y's first. So y minus y1 equals m times x minus x1, where again, x1 and y1 are some point that I know, or point I am given, and of course the slope is given. Here's a good example. Again, this is the next example in your notes package. Determine the equation of the line which passes through 5, 2 and has a slope -3, expressed in slope-intercept form. And slope-intercept form, again, is this y equals mx plus b form. So I start with this formula, y minus y1. I call this point here x1 and y1. So I go y minus, the y1 value is 2, equals my slope, which is -3, and then my x value I don't know, but my x1 value is 5. And I want this in this form, so all I have to do is move the -2 to the other side, eliminate the bracket, and collect like terms. So y would equal -3x plus 15 plus 2 is plus 17. Okay, another example. Determine the equation of line passing through -3, 1 with a slope of 2, and again expressed in y equals mx plus b form. So again, I use my fancy new formula, y minus y1 equals m times x minus x1, and this point here is my x1 comma y1. So I go y minus 1 equals 2 times x minus -3. Remember that minus a -3 is plus 3. Okay, so from there, I go y equals 2x, 2 times 3 is 6, plus the 1 when I move it over, And that's the method you use to solve equation problems where I am given one point and a slope, and I'm asked to find an equation. Good luck on exercise 13.